Section 8.3, Temperature and Volume, Charles's Law. In this section, we're going to see the relationship, hopefully, between temperature and the volume of a container. When the gases increase in their energy because of increased temperature, and you wonder why if you leave a can out in the sun, it increases in size in the summer. This is this section all about that. So if we increase the temperature of a gas sample, the kinetic molecular theory states that the motion, the kinetic energy of the gas particles, will also increase. Now, if the amount and pressure of the gas is held constant, then the volume of the container will increase. So our learning goal is to use Charles's law, the temperature-volume relationship, to calculate the unknown temperature or volume when the pressure and amount of gas do not change. So in Charles's law, the Kelvin temperature of gas is directly related to the volume. Directly related, unlike back in Boyle's law where it was inversely related. So it's directly related. And we have our equation, V1 over T1 equals V2 over T2. Now we're assuming in this case we're holding pressure and moles of gas constant, and so when we do, if we heat up this sample of gas, then its volume is going to also increase. If we keep the pressure the same, the volume has to increase because that the increased energy in the gas molecules from the increased temperature is going to need more space to expand. So here we have our equation. V1 over T1 equals V2 over T2. Make sure you have that equation. Now, if we need to solve for an unknown, we just are going to rearrange our equation to solve for it. So if we needed to solve for the second volume, then we're going to multiply by T2 on both sides to rearrange to get volume all by itself. And so you'll see we have volume times T2 over T1. Now then, to solve Charles's law expression for T2. Okay, well, in that case, if T2 is what we want to solve for, then we would need to get rid of everything. Well, this is one of those cases that I would think it would actually be easier to do the old math saying cross multiply and divide, and then we could do that. And so that's exactly what they say here. T2 times V1 equals V2 times T1. At this point now, we can see how to solve for T2. Let's divide through by V1 to get T2 all by itself, and so we did. Now a balloon has a volume of 785 milliliters at 21 degrees Celsius. If the temperature drops to 0, what's the new volume of the balloon at constant pressure in moles? Well, first of all, we need to think about this. We are cooling it down, so it's a direct relationship with volume and with temperature. So if the temperature goes down, so does the volume. So our answer is going to be less than 785. Now the other thing is we have to remember it has to be converted to Kelvin when we're dealing with our temperature and gases. So in this chapter, always convert your temperature to Kelvin because that's what these gases are proportional to. So the first thing is we got to convert to Kelvin, like I said. So T1 is not 21, it's 21 plus 273, i.e. 294. And T2 is 0 plus 273. Now then, we need to solve for the second volume. So we've rearranged to solve for V2. So we know that V1 is 785. And our second temperature is 273. And our first temperature is 298. And so our volume is 729 milliliters for our ending up volume, which is exactly, we predicted it would be less. And yes, it is less. Now then, here let's do this problem. A sample of oxygen gas has a volume of 420 milliliters at a temperature of 18 degrees Celsius. At what temperature, in degrees Celsius, can't believe they said that, will the volume of oxygen be 640 milliliters, assuming pressure and moles of gas are constant? Press pause and see if you can solve for T2. Okay, well, first of all, we know that our temperatures must be in Kelvin. though, even though they want the final answer in Celsius, we can't do this problem in Celsius. We have to do this problem in Kelvin and then convert back to Celsius at the end. So the first thing is we need our first temperature, which, let's see, is 18 degrees Celsius, so we're going to change it from 18 plus 273 is 291. Okay, now we have the information that we're going to proceed. We need to find T2. So we have our first temperature, which we just calculated, put it in Kelvin, 291 Kelvin. We have the second volume, which is 640 milliliters. We have the first volume, so the second volume is going to be over the first volume, 420. And so your answer is, your first part of the answer is 443 Kelvin for our temperature, but let's go ahead and they wanted us to convert it to degrees Celsius, so 443 minus 273 is 170 degrees Celsius. The answer was back here at B. So that's kind of neat that with these gas laws and by applying the different kinetic molecular theories, that if we know 3 out of the 4 parts of the formula, we can solve for the unknown. So if we know the volume and temperature of something and we change the volume, we can then predict the next temperature. If you think about it, that's like really amazing. Now then, here's our learning check. Press pause and come back and see your answers. So pressure increases if the volume decreases at constant temperature in moles. Yes. If the temperature decreases, gets less, then the volume is going to decrease if we're having that relationship. Now then, see, pressure decreases when volume changes from 12 to 24 and volume increases.